Hi guys, for this term I will be your PLA and my name is 在阳中 here. Oh, I should write it in another color. Maybe red. And this is my email zzhong2 at wpi.edu, and just feel free to email me if you have any problem, like anything you don't understand or you feel confused with the material or with the homework. You can email me and I will answer you as soon as I see them. So in this conference, what I do, I will basically go over some basic concepts. They are introduced in the videos by professor posted on Canvas. You can go to modular and find all of these videos. So here. So professor introduced some row operation in video 1. Some basic knowledge about vector and how they operate in video 2, and in 3 it's about the vector matrix. In the last video he introduced like the concept for linear independence and linear dependence and how to determine a set of equations so a matrix is linear independent or dependent. So we can start here. And they will give you a question, like they will give you a set of equations and ask you how many solutions for the variables. And it can be either unique solution, infinitely many solution, or no solutions at all. When it's unique solution, it will be linearly independent. And if it has infinitely many solutions, it's linearly dependent. And if it's no solutions at all, it means the equations are inconsistent or contradictory to each other. So for example, if you have 2x equals to 5 and 2x equals to 8, like it just doesn't work, right? So for this kind of matrix, it will be no solution at all. And what does linear independent be? Why is it important? The thing we need to know that the function, the matrix is linearly dependent if and only if they are collinears, which means the vectors are lying on the same line. It also means that at least one of the vectors in the set can be defined as a linear combination of others. To give an example, if you have 0, 2, oh, what happened? It's too high. I will put this here. If you have two vectors, one is 0, 2, one is 0, 4, and you can draw it. It's going to look like this, and another is going to look like this, and the second one is just a multiplication of the first one. So these two are lying on the same line, which means it's not linear independent. And we can also write this as not Li. Okay, and we can continue. For the row operation, there are 3 things we can do. The first is scaling, second one is replacement, third one is interchange. How do we do scaling? If we have a row which is 4, 2, 2, the scaling, we can make the leading number 1. In order to do that, we can do the 1/4 of this row, and it's going to be 4 over 4, 2 over 4, and 2 over 4, and 1 over 2, 1 over 2. So as you can see, the leading term is going to be 1. And for the replacement, it means that we do some operations to one row based on another row. So for example here, we want this 2 to be a 0 because we want to have 0 above all the 1s. In order to do that, we can do row 1 minus 2 row 2. So it will be 1 minus 0, which is also 1. 2 minus 2 row 2, so it's going to be 2 times 1. 2 minus 2. And 1 minus 2 times 2, so 1 minus 4. And this will stay the same. And this will be 1, 0, negative 3, 0, 1, 2. As you see, this term just becomes 0. Our interchange is once you have matrix look like this and you see the first number is 0, how do you make it a 1? So you just replace row 1 with row 2, like just switch them between. So we will have 1, 2, 3 and then 0, 1, 1. It doesn't matter with the order, you can switch any line you want. So why are we doing this row operation? Because we want to have an REF form or REF form, which is reduced row echelon. So it will this one, you don't need to look at the method, just look at the form. It will be like this. So as you can see, in every row, in the first row, it will start with a 1, and then all the numbers below 1 will be 0. This one, it means it can be any number. And in the second row, after 0, it starts with a 1 again, and all the numbers below it 0 again. And here's 1 for the row 3 and 0 below it. And that's basically the REF form we want. Okay. Then we can go to web work. And this is problem 5. So I look at the statistic and found that many people didn't do this question right. I mean, they finally did it right, but they attempt multiple times. So but I think it will be too time consuming to go through it step by step. So I will just introduce the basic concept. So here we rewrite it as this. We need to do the row operation. First, we need to make this 10 a 1, because remember, always the first thing we do is to make the leading number a 1, the leading coefficient a 1. So in order to do that, we do the scaling here. And this is row 1 times 1 over 10. And this is 7 over 10, and then 9 over 10. So we successfully make this a 1. And then the second step, not the second step, but after that, we need to make sure all the numbers below 1 is 0. So we need to make this negative 7 a 0. In order to do that, we do the replacement. This is replacement. So we just add 7 times row 1 to row 2. So negative 7, we know it adds 7 and it will be a 0. So this add 7 means to add 7 times row 1. So here we just do the row 2 plus 7 times row 1. And this will be negative 7 plus 7 times row 1. And 10 plus 7 times row 1. So 7 times 7 over 10, which is 49 over 10. And the last one is the same. So 51 plus 7 times 9 over 10. And I didn't calculate this. I calculated here. Yeah, and then we make this coefficient a 0. After that, we will make the leading coefficient in row 2 after the 0 a 1. So here, in order to do that, we simply, because this is 149 over 10, we know that 149 over 10 times the reciprocal, so times 10 over 149 will be a 1. So we just do this to this row. And then it will be row 2 times 10 over 149. This will be the same. And yes, and now we get the 3 number correct. After that, we need to make the numbers above this 1 a 0. So here, to do that, we do the replacement again. So here, row 1 minus row 2 times 7 over 10 in order to make it a 0. And also we need to do it to every number in this row. And finally, we reduce it to our EF form here. And we know that if we have 1x plus 0y equals to 3 and 0x plus 1y equal to -3, we can rewrite at this form. So in the same way, we can rewrite it like this. The 0y just cancel out, 0x cancel out, and leaving only x equals to 3 and y equals to -3. I didn't write out the answers because I don't know if I'm allowed to do that. I mean, just writing out the answer, but I will give you the basic concept, and then if you follow the step, you will definitely know like what the answers will be. And the intercept, after that they ask you what's the intercept, what's the x-intercept and y-intercept for the red and green line, I remember. And you can see that the red line is increasing. I mean, no, the red line is decreasing, right? And the green line is increasing. So you can rewrite the function like this. So what's the function? Here, 10x plus 7y equals to 9, and -3x plus 10y equals to -51. So you rewrite it, it will be y equals to 9 minus 10x then times 1 over 7, and y equals to -51 plus 7x then times 1 over 10. You rewrite it here. And you see the coefficient for x is -10. So this line will be negative. It's going downward. And here the coefficient is +7. So it's positive. It's going up. So we know which one is the red line, which one is the green line. Let me check the problem. That's problem 5. Oh my god, my authentication just failed. Okay, it doesn't really matter. I will just keep explaining. So we find the decreasing line and we want the intercept point. It's easy because we have the x equals to 0, right? They have like something like A0 and ask you this value, and you only need to plug it in back and then calculate the y value, and then you will have the intercept point. For this one, for the green line, it's the same. They gave you the a something 0, so y equals to 0. You just plug it here and calculate for the x value. You will get the intercept. And here is the hard part. They also ask you for the inverse. I guess that's the second question of the inverse of this one. To calculate the inverse, you can look at this rule, which I write it here. The first one and the second one. So the inverse for a 2 times 2 matrix ABCD will be 1 over determinant of ABCD, then times the D, -B, -C, and A. And also determinant for ABCD, this is a 2 times 2 matrix, will be simply AD minus BC. If it's 3 times 3, it will be like much more complicated, but since our problem is just a 2 times 2 matrix, we don't need to worry about that. So here, the inverse for 10, 7, -3, and 10, we just apply the rule. This is 1 over the determinant AD minus BC, so it will be 10 times 10 minus 7 times -7, then times the dB -C, D -B -C, so it's going to be 10 -7, 7, and 10. And this one, the denominator will be 149, and you just times 10, -7, 7, and 10. It will be each terms time 1 over 149, and you can do that yourself. I don't know if I can give the answer, but it's pretty straightforward. And then I will go to problem 7. Give me 2 minutes to open the question. Okay, find A and B such that I guess in this course they ask you a question. The first thing you do is to rewrite it in an augmented form, augmented matrix, which is like this. So you just take the coefficient and make it equals to 19, 7, and 24. And one way to rewrite it, I can rewrite it for you. So it's 1a plus 6b equals to 19. Then 1a plus 2b equals to 7. And then 3a plus 7b equals 24. And you can rewrite it as this. After you write it in the augmented matrix, you can do the row operations just as what I did before in order to get the correct form. So the leading term 1, all the number below it 0, and the second leading term 1, and the number above and below it 0. Here. Okay, I will go through it. So we have the leading coefficient 1 already. We just need the numbers below it 0. So for row 2 and row 3, we simply do row 2 minus row 1 and we can get a 0. But you can also do it the opposite way. You can do row 1 minus row 2. Wait, can you? Wait. Okay, just do row 1 minus row 2 minus row 1, and that 1 minus 1 will be 0. And row 3, because it's 3, so it will be row 3 minus 3 times row 1. And you perform the same thing to all the coefficients in this row. And get 7 minus 18, which is negative 11. And 24 minus 57, which is negative 33. Okay, so this is correct. The second leading term, row 2, column 2, you want it to be 1. In order to do that, we can see this is a negative 4. So we can simply times its reciprocal. I mean negative reciprocal? Just reciprocal to make it a 1. So negative 4 times negative 1 over 4 will be 1. So you just do this to all the coefficients in this row. And it will be negative and 1, and then negative 12 times a negative 1 over 4, which is 3 here. Okay, and to make this 2, 0, we do the row replacement again. So row 1 minus 6, row 2, and row 3 plus 11, row 2, to calculate that. And finally, you have the star EF form, and we rewrite it as 1a plus 0b equals to 1, and 0a plus 1b equals to 3, and 0 equals to 0. So here I need to clarify something. So here we can see that there are only 2 columns. If there are only 2 columns, it means it has only 2 variables. So it will be x and y. But if it has 3 columns, it will be x and y and z. But for this thing, I will just talk more about it in P8 problem 8. So for the last one, 0 equals 0, you can also write it as 0a plus 0b equals to 0. So we can have this solution, and this solution is also unique, as a equals to 1 and b equals to 3. And that's problem 7. Problem 8. Give me 1 second. Problem 8. Yeah, The problem 8 is what I mentioned, as they ask you how many solutions in a matrix, and you need to know. And the easiest way I can think of is just to look at the result. Look at your result and rewrite it in the XYZ form, and then it will be really clear to see. So the first one is 1 0 0 0 1 0 0 0 0, and then 3 negative 1 negative 4, and just rewrite it. Here it has 3 columns, so we know that there is a z variable. The original one would be, oh, there's no original, but like, because there are 3 columns, we know that there are 3 variables. So the last one is going to be z, 0 times z equals to negative 4, which is impossible, because whatever z is, it can never be negative 4. So this one will be no solutions. And the second one I will write it 1 0 0 0 1 0 0 0 0 and negative 1 3 0. The same thing, it has a z, and the last one will be 0z equals to 0. And we can see that z can be anything for this to be true. So it will this matrix will, this set of equations will have infinitely many solutions. Infinitely many solution. The third one, 1 0 0 0 1 0 0 0 1 0 2 3. We rewrite it, and we can see this is just the unique solution. And for a linear independent, I think we can just remember that a set of equations can only be linear independent when there is an unique solutions. If there is like any other, like more than one solutions, it will not be linear independent. And the last one, 1 0 0 0 1 0 0 0 0. The first time I got this wrong because I read it as 0z equals to 0, but actually that's not right, because see, there's only 2 columns, so the original set for this one will can only be x plus 0y equals to 0, and then 0x plus y equals to 0, and finally 0x plus 0y equals to 0. So here both x and y are 0, and the third one is true. So for this one, it's still unique solution, and it's linearly independent. Okay, problem 9. Problem 9 is really similar to problem 8. It's basically the same. If you feel like you don't understand it, just rewrite it in another form. Then you will get to know how it works. For A, it will be 0z equals to 1, so it's impossible. And for the second one, I need to rewrite it. 0 1 0 0 negative 19 and 0 0 1 0. So 3 columns, we have x, y, and z. Here it will be 0z equals to 1, and 0x, 0y, 0z equals to 0 here. And the first one can never be true. So this set of equations can never be true. There's no solutions. For C, yes, as I just said, the last one will be 0x plus 0y. So it can still be true. And we know from the original equation that x equals to 10 and y equals to 13. So this will be unique solution. Yes, it will be unique solutions, because you plug this in and you see this still be true. So this one is a unique solution. And last one, they only have 2 rows. I read it here. So 1, 0, 0, 0, 0, 1, then 15, negative 12. And we write it as x equals to 15, z equals to negative 12, and y equals to question mark because we don't know. So here y can be anything. So it can literally be like anything. So it will have infinite solutions. That's basically for 9. And problem 2. When I look at the statistic, I didn't think you guys have many problems with problem 2. But when I try to do it myself, I mean by hand, it gets super complicated because the number just gets to a lot of denominator stuff, and it's too time consuming. I don't think I will do it here. But if you want to do it, just it follows the same rule. You will make this leading term 1, and then make 2 number below it 0, and then make this the second leading term 1, and the number above and below it 0, and then this one 1, and this 2 0. If this one is 0, you don't need to worry about this 2 number. We only need to have 0 when there is a 1. I mean above or below it. So that's the basic idea. And if you are very confident that you understand the concept, I will tell you that you can go to Google and search Symbol Lab calculator. I will write it secretly here. Wait, Symbol Lab calculator. Yeah, and then go to the linear algebra calculator and plug this thing in, and they can calculate for you. But I don't know that if students can use calculator for their homework. So like, if you want to understand concept, I would suggest you to do it by hand. But if you just confident and you use calculator, no one else will know. So, yep. And when you use symbolic calculator, they will do something different than what I just mentioned, because they will reduce it to REF form first, and then to REF form. So for an REF form, it's basically you only need to make sure the numbers above zeros are non-zero. It doesn't require the leading term, the leading coefficient to be 1. So an REF form of this will look like this. You can see the leading term is not 1, but as long as it's non-zero, it's okay. And 0 here, this two numbers below the leading term will be 0. Here is 0, and this are all non-zero. It's all non-zero. And after doing this, they then reduce the REF to REF. In this case, you can calculate it yourself. And after you get the answer, for example, you get 1 second. If you have this, you only need to rewrite it. You know that an A times X plus B times Y equals D, and C times Z. Oh, sorry, I made a mistake. It's going to be 8 times Y, and B times 0 equals to D, and then C times Z equals to E. And then whatever, just ignore this. If this is like a G, it will be G times Z equals to F. And you solve this, you will get the answer. And that's the basic idea. Okay, I think that's everything for web work. if you have further question, you can email me and I will answer them. You can. I will strongly suggest you to go over professors' videos because they are really helpful. Like some concept I didn't really remember them in the first place, and then I watch all the videos. I think I understand them, and he explained them very well. So just watch videos and then do the web work, which is I believe not due this week, but it's due next week. So no hurry. And this is everything I prepared for the conference. I'm sorry for the late. Also, my apologies to people who came but just couldn't enter my Zoom because like there was something wrong with my schedule and I didn't really I didn't really prepare it, so I was late. I missed my own conference. So I will record this whole video and then send it on Canvas if possible. If I can't, I will try to send it to your emails. And that's all. Thank you very much.